Hey everybody. Thank you, Kian, for doing the introduction. I have so many slides and I already need to speak fast, so that just saved me some time. So this is Felix Geisendorfer, that's me. I do Transloaded. I was one of the people pulling off Nodecopter. The other people are sitting over there, Robin, Tim, Torsten, and a few people who are not here. And the video encoding thing, that's our product, so check this out. So we make money and I can do more Nodecopter. So anyways, this is not about Nodecopter or Transloaded. This is about a little battle that I had a while ago on GitHub. And for this battle, I chose to make JavaScript fight versus C for performance. Raise your hand if you think that's a stupid idea. Okay, I'm not as insane as I thought. Many people would share my insanity here. A few hands went up, but it seems like some people want to see this. So basically, JavaScript versus C, it's kind of like good versus evil, right? Or it's a good parts versus evil, at least. Turns out if you want to fight C, you kind of have to get the bad parts out as well. So bad parts will also be shown. So faster than C. For the title, I want to apologize. Sorry for the title bait. We're not going to directly compare like JavaScript functions versus C functions and expect JavaScript to be faster. That would be bullshit in most cases. What we are going to do is we're going to compare JavaScript versus C add-ons for very specific tasks, in my case, for parsing a binary protocol, so MySQL protocol in particular. So let's get started with the story. I've been in the Node community fairly early on. I was number 23 on the mailing list or something. And so we built this product, Transloaded, with it. And what we wanted to do is we wanted to talk to a MySQL database. But in early 2010, which was actually a while after Node picked up momentum, there was still no MySQL module for Node.js. Such a thing simply did not exist. People at that time were fucking around with some proxy servers that was exposing MySQL over HTTP written in Python or something. But there was no native client Node driver. All we really had was no SQL libraries. Go figure. I guess those were easier to talk to because CouchDB was getting pretty popular back then and it had an HTTP interface. But that's actually not quite true, because in early 2010, there was somebody, that's him right here, Masui Drive. He submitted a patch to the Node mailing list. I think it was related to promises, which we long got rid of. But along with this patch, he was like, by the way, I have implemented a MySQL product driver for Node.js. And I was like, what? And I went and checked it out. And it turned out it was real. He had a working MySQL module. But what was really surprising was, his module was written in pure JavaScript. There was no C or C++ anywhere to be found in it. That's pretty crazy. Back then, everybody assumed we would have to do binding to libmysql, and that would be the only way to do it. And it wasn't quite clear how we could get a blocking library, like libmysql, to talk to the non-blocking world of Node.js. That wasn't quite figured out yet. What was even crazier so about this module was that it was done before buffers became usable. So this guy did a MySQL module in pure JavaScript and didn't have buffers. So his parser was using JavaScript strings. Give a round of applause for Masui Drive, because that's one of the craziest things people have done. And before we get to the next part, a little piece of Node trivia. Who here knows that buffers used to be called blobs? Well, it's really hard to know because it lasted very short. They were called blobs for 3 minutes and 15 seconds. And I'm just bringing it up because I'm pretty sad that buffers are not named blobs, because I'm often talking about buffering data, but I don't necessarily mean binary data. I may just mean increasing the size of a string or of an array. And so blobs would have been a much better way. So rest in peace, little blobs. You had a very short but interesting life. Anyway, so what Masui Drive's module really did for me is it showed me that MySQL can be done without libmysql. And I was really excited about this. And also shortly after he released his module, Ryan landed the blobs that then became buffers. And those made it obviously much better and easier to work with binary data. Unfortunately, Masui Drive never finished his module and didn't continue working on it, and was still based on strings. So I decided, hey, if he can do it with JavaScript strings without buffers in pure JavaScript, I may be able to do it, pull it off now that we have buffers and that I can look at his code. So that's what happened. I created a module called NodeMySQL. I not only stole his idea, I also stole the exact name for the module. And I went ahead and did it. And so after 3 months, I had a working module, and people started using it, and it seemed like we could solve this problem of having a MySQL module in Node that's just in pure JavaScript. But, so you guys know how it is in life. No good deed goes unpunished, right? So this guy actually also knows about it, Sir Isaac Newton. He put it in a little different way, into a more scientific way, and he called it the third law of motion. And the third law of motion is pretty much when a first body exerts a force F1 on a second body, the second body simultaneously exerts a force F2 equals minus F1 on the first body. This means that F1 and F2 are equal in magnitude and opposite in direction. So, I don't know about you guys, and I don't really know about Isaac Newton, but I imagine that if he lived today, he would be doing something. Maybe he would be programming. And if he did programming, I think Isaac Newton would probably be on GitHub. And so, maybe if he was on GitHub, and I'm making this up entirely, maybe there would be such a thing as a third law of GitHub. And this third law of GitHub could look like this. When a first person pushes library L1 into a remote repository, a second person simultaneously starts working on a second library L2, which will be equally awesome, but in a different way. That's why we love GitHub, right? It just fosters contributions and new modules, and good stuff comes up all the way. But sometimes it can also be annoying, which was what happened in my case. So shortly after I released my MySQL module, people started to figure out how to do these bindings to libmysql. And Zanis was one of the first guys who did a binding to libmysql called NodeMySQL libmysql client. And it was different in that it was binding to the C library that ships with MySQL. And it was awesome because it was pretty fast. And so I've done a little benchmark on it, comparing it against my old version of MySQL. And the benchmark is basically parsing 100 megabytes of binary data that normally come from a network, or in this case do come actually from a network. And these include 100,000 rows of MySQL result data. This data has 5 columns, kind of like a blog post: ID, title, text, created, updated. And so what the database driver has to do for this, it has to go through these 180 megabytes, and it has to create 100,000 objects, one for each row, and it has to create 500,000 keys, one for each column, and 500,000 values, one for each column value. So that's pretty much the work that needs to be done. And it turns out I thought that my old parser was pretty fast because I modeled it after Ryan's HTTP parser. It didn't buffer up anything. It was written in a very efficient way, or at least what I thought was an efficient way. But it turns out this happened. It didn't look like my driver was fast at all. Mine is on the left side. MySQL 096 is the old version, and on the right side is MySQL libmysql client, which was much, much, much faster. So my initial reaction was, of course, libmysql is written in C. My library is written in JavaScript, and C is fastest in JavaScript, right? I mean, I thought that was the end of the story. I thought I would stop here, and there's not much. Maybe I can get 10%, maybe 20%. But I was pretty certain I couldn't get a 2x improvement. But it didn't feel right, because, I mean, if you've read the Node homepage, it's going to make scalable, fast network programming easy, and it's going to solve world hunger and a bunch of other things. So V8 would be super fast, turning my JavaScript into assembly, and Crankshaft would make it even faster by analyzing it while it was running and creating new assembly code. And, I mean, Node.js. I mean, it must work. So I was questioning myself, was I living a lie? Had I been lied to? Was Node not the unicorn that I've been promised? It turns out kind of, yes. Because V8 and Node are just tools. And I don't know everything there's to know about performance, but I'm pretty certain about this. Performance itself is not a tool. You cannot just plug performance in or download performance or install it. It's not how it works. performance is actually much closer along the lines of hard work and data analysis. So what I did is, and by the way, if anybody ever tells you otherwise, they're probably full of bullshit. It takes hard work, there's no silver bullets. So what I did is I basically sat down and it was like, okay, I have to learn why my library is slower. And I started profiling it, I started doing a bunch of things, and I'll talk more about them in a second. But the end result was that I came up with a new parser. And I was actually able to be quite as fast as a C library. On the right side, the blue column is my current version of my module, MySQL 2.0.0 Alpha 3. And it seems like I did it, right? JavaScript being faster than C for this particular task. Well, if it only was so easy. So the third law of GitHub, I am actually pretty convinced it exists. Because what happened after I submitted this talk, this guy came along, Brian White, MSC Dex. I don't know why he has a Windows terminal as an avatar, but he wrote a library called Node Maria SQL. And Node Maria SQL is another binding to libmysql, but he's using the libmysql for Maria SQL, which itself is a fork of MySQL. And they made it non-blocking, made it faster, made it better. So here's what happened. Shit, right? So I don't know. I was pretty unhappy about this when this happened, because I thought, here goes my talk, here goes everything I was going to tell you guys. So what do you guys think? Is this the time to give up? No? Okay, never. Never going to give it up. So I've been hacking on this new parser, and it's totally unfinished. It cannot even connect to a database yet. It's just testing my hot loop that is really relevant for this benchmark. But it looks really promising. So this new parser is actually 2 times faster than my old parser. And actually, there's a flaw in this benchmark that I'm going to show in a second, which means it's actually even faster than what you can see here. So anyway, what will happen? Once I integrate this with my current library, will somebody just come along and create yet another faster parser? I don't know. I hope not, and this time I have reason to believe it won't happen, because I think we're getting closer to the end game. And I think the end game in this case is the last bottleneck of creating JavaScript objects. So the main thing my parser does at some point is it takes a buffer slice, so some bytes from offset here to this other offset there, and it turns it into a string, or into a number, or into a date object, or what you have. So it's creating JavaScript objects. And what does the C++ module do? The C++ modules also create JavaScript objects. They just call the v8 function to create it for them. But given that v8 is pretty good about what it does, and it's fairly well wired together, I believe at this point the most work, the most time will be spent in v8 itself. So unless v8 gets dramatically faster, nothing will change. We're going to hit this boundary. And even if v8 gets faster, we'll probably get equally faster my modules and the C++ modules, unless the parser code becomes a bottleneck again. Anyway, it's all science fiction, because at this point the MySQL server already lost. We can, with a single client, fully saturate one MySQL server on a single core. We can do more than, I don't know, 6,000 megabits a second on a single core of parsing MySQL data. So assuming we have more than one client, this thing is not going to deliver as much. So let's get to the meat of this. So how did I do this? How can you really write fast JavaScript? Before we talk about this, let's talk about what doesn't work. One thing that actually turned out to not be working well for me is profiling. Profiling turns out to be a pretty good tool for spotting small functions with stupid algorithms performing many iterations. So if you have a single function like your parse function that iterates over data in a stupid way and does it stupidly, the profiler will tell you, hey, this function is slow, go check it out. Well, in the case of my old MySQL modules, this didn't help me much, because I was taking inspiration from Ryan's HTTP parser, which is basically one big switch statement. And so I had one parse function, and all my code wasn't there. So the profiler told me your parse function is slow. I was like, fantastic. How am I going to use this? It actually also turned out that later on, I was pretty good at predicting where my hot code path would be. So I really needed a tool that told me how to make things faster, not where my slow code was, because I already knew that. But it is good for other stuff where you don't have an intuitive understanding where your slow code is. So yeah, it's bad for complex functions with many primitive operations. So if you're really spending your time on just like manipulating strings or changing objects around, then the profiler will generally not be able to point you to the right line of code where things are going wrong for you. Another thing that does not work is taking performance advice from strangers. So actually, if I'm going to give you any specific performance advice today, I want you to ignore it. I want you to like literally ignore it completely, because the worst thing you can do in the performance performance battle is to just take something somebody else tells you to do and do it in all your code. And I see it all the time. I get pull requests from people who change my for loop so the length property of an array is not accessed every time. And it turns out actually my test is so optimized at this point, it's never my bottleneck. The V8 engine seems to take care of it. But it doesn't matter, because even if it was a bottleneck, I first have to show that it is a bottleneck in my particular case. And not just a bottleneck in some case, because some of the operations I do in JavaScript, I may be able to do 50 million of these operations per second. But if I have another operation that I can only do 10,000 a second, that's the one I need to optimize, not the one that's already really fast. So take performance advice from strangers only in the form of ideas and inspiration, ideas for what to try out, but make sure you verify it. Make sure you verify it in your context and what you are doing. Don't follow it in a cargo code style way. So what does work? I found that for me, only one approach has consistently produced good results. And that approach is benchmark-driven development. It is fairly similar to test-driven development. So you don't always use it. If you just want to prototype something quickly together, don't use benchmark-driven development. If you don't care about performance, don't use benchmark-driven development. But if you've already done something, it's working as you want it to, and now you want to make it faster, then it's a good thing to use it. It's good when performance is an explicit design goal. So benchmark-driven development is really easy. You create a benchmark before you create any code. If you already have the code you want to benchmark, throw it away, put it in a different file, start a new one, and then only take over as little code as possible from your old code and continue running the benchmark and see what lines of code have what performance impact. Because that's what you really want to see, and what the profiler doesn't tell you, is that this line causes a 20% performance hit. So basically, if you want to try this at home, just create a function called benchmark. Don't get any fancier. Create this loop while true. Capture when you're starting your benchmark, run the benchmark function, get the duration of that benchmark, and print out the duration. Now, initially, you're always going to get 0, which means you've written the fastest JavaScript program on Earth, so it doesn't take any time. That's very nice. Since V8 is so fast, you can probably even do a lot of work in the benchmark function and still get 0. Some people are trying to solve this problem by getting better timers with, I don't know, microsecond accuracy in Node, but I think that's the wrong way. Just make sure that your benchmark function ends up doing enough work to run for, I don't know, 2, 3, 400, 500 milliseconds, so you get reasonable results here, and don't worry so much about the timers. So make sure benchmark does enough work. If that means having another big loop in there that just repeats the same thing several times, and then go and do that. So the next step is you implement a tiny part of your function, as I just said. So in the case of my MySQL libraries, that usually meant I would start out with a new parser, and all the new parser would do is parse the headers of a MySQL packet. So that's only the first 4 bytes. The first 3 bytes are going to tell me how many bytes my package is going to have, and then the next byte would tell me the number of the package. And so I would only parse the headers, skip over the actual data, and go to the next package. And then I would try to optimize this. So I would look at the impact of every line that's required to do this header parsing. I would tweak that code and monitor what it does for the benchmark. And it turns out these VMs are just too magical. Some really unintuitive things happened while I did this. I changed one line from something that looked like it should be just as fast as the other one, and it produced drastically different performance. And since the V8 guys are really on it and are changing the engine all the time, I don't think it's worth it to memorize all these rules and performance tips you're getting. I think it's worth to actually try it out in your context and see what actually works right now. So I'll give you some example results just because they're interesting, but please don't apply them to anything unless you're going to write MySQL database drivers. The one thing that I found is that try catch is okay. I've been told that if you wrap your parse function in a try catch, it would significantly impact the performance. Well, maybe it does for some cases. It didn't in mine. I did learn that a big switch statement is actually a bad idea in JavaScript. My understanding is that it actually gets converted into a big if-else statement. And so the later cases will actually be slower to go to. So I got rid of that in my parser design. Another reason why I used the big switch statement is because I thought function calls would be expensive. But it actually turns out they're super cheap. I'm creating function calls or making function calls whenever I need them in my parser, and they're hardly the bottleneck in any case. So I hardly ever manually inline code anymore. So V8 engine does this perfectly for me. And another big realization was that buffering is okay. One of my explicit design goals for the first version of MySQL was never buffer anything. So if you get 5 bytes of network data, but it's only a partial package, don't wait for the rest. Try to process these 5 bytes, already analyze them as much as you can. That's very much what the HTTP parser doesn't note. But it actually turns out, for my JavaScript and what I'm doing with my problem, not buffering means more housekeeping. I need to keep track of more state. I need to perform more operations. So it slowed down everything. Now I'm just buffering all packages. And I don't know, there may be 1 megabyte if there's a really big row in there. But unless somebody's putting a file in the database, it's not going to matter. If this case later becomes relevant, I may be still able to optimize that case. But for now, buffering is actually totally OK. And here's my favorite one. My favorite is this one. I have this function in my parser that parses a row. And what it does is it basically takes the columns, which is an array with the field names that I have. So column has a name property, and a parser, which allows me to take already received network data and interpret it. So every time I would parse a row, I would loop over all the columns, and then to my row object, I would assign the columns .name value or key, and I would say parser.read column value. And I thought this was pretty much the most efficient way to do it. But it turns out there's a way to make it faster. And I'll let you guys read this for a second. This is what I ended up doing. OK, so if you've gotten it, you probably have a good idea. If not, what this does is pretty much every time I receive the information about the columns I'm going to parse, I receive that before all the rows come in, I would create a new parser, a new parse row function. And that new parse row function would be optimized exactly for the kind of rows I would receive. So instead of this code right here, I would generate myself this code right here, which is basically just the unrolled loop. And it turns out this was actually a huge win in my performance battle. And it got me another 20% when I already thought I was hitting a wall. So eval is awesome. Actually, I talked to Eric Corey, one of the previous V8 engineers, about this, and he told me he's not friends with me anymore if I put it on my slide. So I have to change it a little bit. Eval is not awesome, but it's eval twin new function is awesome. That guy you can use. The difference being eval has access to the surrounding scope, while new function does not. So once you've already done this, you're already pretty good. You can write fast stuff, but you're still not really understanding it. And understanding it will get you to the next level. So let's talk about data analysis. And shit, I'm already talking fast. I need to go faster. For data analysis, here's my approach on how to do it. You already saw the console log statement where I was outputting the duration. Basically, output your data to standard out like this and produce your data points as tab-separated values. So if you log more data for each benchmark run, put a tab in between it. And then add as many virtual machine or operating system metrics as you can get your hand on. So for example, the heap usage, the heap total, the process size, anything you can find. And last but not least, never mix data and analysis. most benchmarking tools out there do that. Like JSPerf, you put in 2 JavaScript functions, and it will run them against each other, and at the end it will tell you this function is 2% faster or something. And this is nice, maybe useful in some contexts, but it hides so much information. What you really want is a tool that produces raw data that you can then analyze with something that's really good. So for example, the R programming language is really good when you're using ggplot2, which is a library that makes the graphing easier. So my tool chain looks, I run my benchmark, I tease the results in a TSV file, and then I use makefiles, ImageMagick, the R programming language, and Skitch to get my data analyzed. So almost done here. Why am I doing this? So I was showing you this benchmark and a bunch of other benchmarks earlier. It turns out all of them were bullshit, because I was just showing you 2 pretty graphs saying this is faster than this, but they weren't going any deeper. They weren't looking what goes on under the hood. And you can see how important this is if we take a different look at this data. So this is the same data, but instead of showing you 2 bars of the medians compared against each other, I'm showing you every data point in my benchmark. So there's something weird in here, right? Why is there this hole? Why is there this cluster of dots in the top and the cluster at the bottom for both benchmarks, for MySQL 2 and my new parser? I was really stumped about this, but since I had my data recorded, I could analyze it deeper now. So here's the same data, but this time I'm plotting the data speed on the y-axis against the number of the run that I was executing on the x-axis. And so it turns out my benchmark in both cases starts out really fast, and then it drops about 10%, and it stays dropped. So it was like, what happened? Why is this going on? Well, since I have all the data that I could get my hands on, I could also look at the heap total. And so the heap total told me that at exactly the point where I was losing performance, V8 decided to increase the heap that my programs were using. It was identical for both parsers, which are independent programs. And we can have another look right here. Here we're seeing the heap used. We can see that V8 it doesn't look like we're initially leaking memory. V8 is constantly reclaiming memory in these garbage collection cycles for both benchmarks. But then when the error comes in, it just gives it more room, and the garbage collection cycles become bigger. And I don't know, this could be anything. It could be a bug in my program. It could also be a bug in V8. We're currently investigating it. But I learned something. I learned that I have a problem, I identified it, and now I can set out to fix it. And that's why I need to analyze this data. So, too long, didn't read. Write a benchmark, change a little code, collect data, find problems, and go to step 2. And you're going to spend weeks on this. It's going to be very hard, but you're going to get the results. There's really not much more to it. And that's all I got. Thank you. Also, all of the benchmarks, code, and everything used to analyze the data is in this GitHub repository. If you have any questions, just open an issue there.